Okay, so today we're going to wrap up Unit 5 talking about some inequality theorems that kind of govern our triangles, right? We've been talking about all these different geometric figures in our triangles, and some things that we want to talk about is understand when you can even make a triangle, and then be able to figure out which angle is going to be the biggest, smallest, which side length is going to be the biggest, smallest, and we do that by using the opposite, whether it's the angles using the sides or sides using the angles. You see what I'm talking about. And then talking about something that's called the hinge theorem. Hinge theorem is kind of weird, but it allows us to tell between two triangles which angles or which sides might be bigger. Okay? So, before we get into any of this, if you can understand this one concept, then you will understand all of what's going on in this particular section, right? So I got a triangle there. The green sides are making one angle, and that red side is the opposite side from the angle that the green sides are making, right? So this red side is opposite this angle, right? Now, let me ask you something. If I wanted to make this angle, angle X, if I wanted to make that measure bigger, right, then I would have to, if I wanted to make that angle bigger, then I would do something like this, right? So now that angle is bigger. What has to happen to that red side in order to make a triangle, right? Well, obviously, that red side is going to have to get longer, right? So what that means is the bigger this angle, the longer the opposite side has to get, right? And that just makes a ton of sense. The smaller that angle, the shorter that opposite side would have to be. And that kind of idea is what most of this section's about, and helps us in trying to figure out biggest angles, longest sides, things like that. And so to put this in your notes, basically what that means is in a triangle, the longest side will always be opposite the largest angle. The shortest side will always be opposite the smallest angle. So the longest side, largest angle, opposite from each other. Shortest side, smaller angle, opposite from each other. And just understand that opposite means exactly like that. Okay, the red angle on the first guy to the red side, and the blue angle to the blue side, right? The opposite just means across from. Okay? But there are a couple of theorems that say exactly that, right? First theorem says that in a triangle, if one side is longer than another side, then the angle opposite the longer side is going to be larger than the angle opposite the shorter side. Right? And again, hopefully that makes enough sense. In other words, here, since AB is longer than BC, then the angle opposite AB, which is angle C, will be bigger than the angle opposite the shorter side, BC, so A. So angle C will be bigger than angle A. The measure of angle C will be bigger than the measure of angle A. We can go the other way also, right? In a triangle, if one angle is bigger than another, then the side opposite will be longer. So in other words, since angle A is bigger than angle C here, then side BC is going to be bigger than side AB. Right? And that helps us rank our sides and our angles in terms of longest to shortest, smallest to largest, or whatever. Right? So we'll use that here. First example, list the sides in order from shortest to longest. List the sides. What? We've got the angle measures, but we don't have the side lengths. So how can we tell? Well, we'll use those theorems, right? The shortest side is going to be opposite the smallest angle. So P is the smallest angle. That means that QR will be the shortest side. The next biggest angle is R. That means the next longest side is going to be QP. And then the biggest angle is angle Q. That means the longest side is going to be PR. So that's how we would rank these. It goes QR, PQ, and PR. and that's why, right? Next example. Next time we're going to rank the angles from smallest to largest, right? Well, again, we don't have angle measures, we have side lengths, but we can do that from those two theorems. Since this is the shortest side, that means the angle opposite is going to be the smallest. So angle B is the smallest, angle C will be the next, and angle A would be the biggest, right? And that's how we rank them. Okay? Makes a ton of sense, right? All right, so a use of this, I don't know, building a stage prop, and it's a large triangular mountain. The bottom edge of the mountain is 27 feet long. So the bottom edge of this mountain is 27 feet long. The left slope is 24 feet long. The right slope is 20 feet long, right? You're told that one of the angles is about 46 degrees and one is about 59 degrees. Question is, what is the angle measure of the peak of the mountain? Well, it's not going to be 46 degrees, right? Because the peak of the mountain is going to be your biggest angle measure since it's across from the longest side. So 46 is out. It could be 59 degrees or it might not. The problem is we don't know that third angle, but we know the angles have to add up to 180. So we could go 46 plus 59 and get 105 and then subtract 105 from 180 and realize that that third angle is 75 degrees. Right? So since the third angle is 75 degrees, that's your biggest angle. That has to be opposite the longest side, which means that the peak is going to be 75 degrees. Okay? Make enough sense? I hope so. Now, next theorem. And this is usually when I put a challenge to students, and I say, if you can make me a triangle that has sides 1 inch, 2 inch, and 3 inches long, then I'll give you an A right now. And obviously I'm comfortable doing that because I know you can't do it, right? And here's why, right? The triangle inequality theorem says that the sum of the triangles of any two sides is got to be greater than the length of the third side. Which means if I'm going to make a triangle out of these three side lengths, then I should be able to add up any two side lengths, and that be bigger than the third side. So obviously 3 plus 2 is bigger than 1. 3 plus 1 is bigger than 2. Makes a ton of sense, right? But 1 plus 2 is not bigger than 3. It's actually equal to 3, right? So I can't do that. Now, obviously, if you add anything to the longest side, then it's going to be longer than any other side in the triangle, right? So in other words, it doesn't make sense to check the first two. That's always going to be true with side lengths. It's only if you add the two shortest sides that you might have a problem. So the two shortest sides added together needs to be bigger than the third side. That's what this theorem is all about, okay? Yeah, the theorem says you need to check all combinations of sides added together, but as we just discussed, it's really just the two shorter sides that are going to create a problem, right? So, we know that we got to make a triangle. Next example, we got to make a triangle where one of them has a side length of 14 and another one has a side length of 10. What are the other possible side lengths, right? Well, there's two situations for this third side. First of all, the third side might not be the longest, right? The 14 might be the longest side. And if 14 is the longest side, that means that whatever our third side is, added to 10, has to be bigger than 14. Right? So there's an inequality that we can solve. Just subtract 10 from both sides, and we find out that the third side's got to be longer than 4. But it can't be as long as we want to make it, because at some point, it starts to get too long. Right? And that situation is where the third side is the longest. If the third side is going to be the longest, then that means we have to be able to add 10 and 14 together, and that be bigger than the third side. When you add those, you get 24. So x has to be, the third side has to be less than 24 whatever long, but it has to be longer than 4, right? you can actually write this as a compound inequality. So x has to be greater than 4, but less than 24. Not equal to. It can't be 4 and it can't be 24, but we can go all the way up to 4 and 24. We'll go all the way down to 4, go up to 24. So there's a minimum and a maximum for this third side length. Okay? Does that make enough sense? A shortcut way to this might make enough sense as well. You can go ahead and make your compound inequality. Basically, if we're going to do this example, we know that the third side, there's a smallest possibility and a biggest possibility for that third side, right? The smallest it can be is whatever the difference of the other two sides are. So 14 minus 10. The longest the side can be is whatever the other two sides added together can be. Right? So that's one way you can do this. Personally, I like to kind of think it through in the two different situations like I did in the previous slide when I'm setting these up. Whatever makes the most sense to you, right? And get you down to this inequality here. Let you know that the side length needs to be between 4 and 24. Okay? All right. You give it a shot with this example. Use whatever method makes sense to you. And stop the video. You can start it back up and check your work. All right. Did you get that the third side had to be between 4 and 26? Right? Again, the two situations. One situation where 15 is the longest side. So add the third side to the 11. It has to be bigger than 15. And the other situation where the third side, whatever you decide to make that, is going to be the longest side. So it has to be less than 15 plus 11, which is 26. Okay? All right. The reason why I like to think about it that way is if, some generic problem sets up to where the third side length is an expression. Right? What are the possible values for x there to help you find the length of that third side? Well, again, there's going to be a situation where 25 is the longest, and if 25 is the longest, then we have to be able to take 2x minus 1, add 11 to it, and that's got to be bigger than 25. So we get 2x plus 10, subtract 10, divide by 2, so x has to at least be bigger than 7.5. But it can't be as big as we want to make it because the third side might actually be the longest. So if that happens, then that means when you add 25 plus 11, that has to be bigger than 2x minus 1. Right? So you solve this inequality. And you find x needs to be less than 18.5 long. Okay? So if you want to write it as a compound inequality, so x has to be between 7.5 and 18.5. Okay? All right. Now, last theorem here for us to take a look at is the hinge theorem. The hinge theorem is kind of weird, so hang in there with me. Right? But basically what it does, excuse me, is that it takes the idea of comparing angles and sides and extending that out to two triangles instead of just doing it within one triangle. Right? I mean, here's what the hinge theorem needs. The hinge theorem needs in two triangles for two sets of sides to be congruent. Right? None of this works unless you've got two sets of sides that are congruent. That's your condition. If two sides of one triangle are congruent to two sides of another triangle, and the included angle in the first is larger than the included angle in the second. Included angle just means the angle in between the sides that we're talking about, right? So there's a couple of things going on. We need to have two sets of congruent sides, and then we're going to compare the angles between them, right? The hinge theorem says if those sides are congruent, and you compare those angles, right? The third side of the triangle with the bigger angle is going to be longer than the third side in the triangle with the smaller angle, right? In other words, since angle V is bigger than angle R right here, that means that side WX is going to be longer than side ST. Okay? That should make a ton of sense. The big thing here is that you have to have two sets of congruent sides or this doesn't work. Okay? There's a converse to the hinge theorem as well. And the converse acts a little bit weird because it still requires us to know that two sides are congruent to two sides. Oops. Right? It still requires us to know that two sets of sides are congruent. But now instead of comparing the angles between them, we're going to compare the sides, the third side, right? So the converse takes sides and helps us decide which angle is bigger. So here, angle C will be bigger than angle F. So the original hinge theorem takes the angles and allows us to compare the sides. The converse takes the sides and allows us to compare the angles. Right? And here's how we're going to use that. First example here. Right? We're given this diagram. We've got two triangles in there. And we know that ST and PR are the same length. And we want to compare. How does angle PST, which is this angle right here, compare to angle SPR, which is this angle right here? All right? Well, first off, because of reflexive, we know that that side is going to be congruent to itself. So, in those two triangles, we have two sets of congruent sides. So the hinge theorem will apply. But since we're going to use the third sides to compare our angles, we're going to use the converse to the hinge theorem. And the converse to the hinge theorem says that angle PST will be bigger, the measure of that angle will be bigger than the measure of angle SPR, because it's across from the longer side. Okay? That's how we can use the hinge theorem. Another way here, right? In this diagram, we know that PR and PS are the same. And then we know that the measure of angle QPR, this angle, is bigger than this angle. Right? Which is longer, SQ or RQ? Well, first off, we have to understand that we've got two sets of congruent sides because of reflexive. So the hinge theorem will apply. Right? So since angle QPR is bigger, that means that this side, the opposite of that angle, is going to be longer. So QR is going to be longer here. All right? How about this one? Can you pick out which angle is going to be larger? Think about that for a second, and then it will be revealed. Okay, reflexive makes these two sets of sides congruent. Since RQ is bigger than SQ, that means that because of the converse to the hinge theorem, angle RPQ is going to be bigger. So that's your hinge theorem. Okay? All right, and that's it. Those are your inequality theorems. Hopefully those make enough sense. If not, come on in and get some help. We'll figure it out. Otherwise, homework's out in Canvas. Get that done by next time.